In this video, we will see how to find trigonometric ratios for angles which fall on the fourth quadrant. So we're going to call these angles as 360 minus theta. So if we consider this angle here as theta, then this angle will be called 360 minus theta. Right, let's proceed. Let's imagine a right-angled triangle with angle theta, for which we are trying to find the trigonometric ratios. And let this triangle sit inside a unit circle from the origin, and let P be the point that it coincides with the circle. So P is also the vertex of the triangle, and P is a point where the vertex or the triangle touches the circle. So if I'm going to move this point P around, let's see what happens. So as I move the point P, can you see the shape of the triangle is changing, and the value of theta is also changing. So let's keep moving it further on. And now our adjacent side is almost 0 here, and theta is almost 90 degrees here. So if I'm going to push the theta to become more than 90 degrees, let's see what happens. So when I push the hypotenuse to the other side, then it starts to form a mirror image on the other side. And this is explained in our previous videos, how this triangle here is actually a mirror image of the image in the first quadrant. Okay, so if we move this point P further down, let's see what happens. So now I have pushed it into the third quadrant. So when I push it in the third quadrant, this is our reference angle theta. So this is the hypotenuse line which is being moved around, and we see an image being formed here, and we have explained this image as a double reflection of the image in the first quadrant. So when you see the young man's playing basketball in the real life being reflected onto the mirror, and when you see his reflection through the mirror on the water, then this is what you would see. So this is nothing but a reflection of a double reflection of an image from the first quadrant. So let's move the point P further on. So as it moves and as it goes into the fourth quadrant, let's see what happens. Let's move it further on to a point P, and let this angle be theta. Right, so let this angle be theta. So then this angle becomes 360 minus theta. All right, so let's call this point P2. Now let's draw another triangle in the first quadrant with equal dimensions. So let's say that they are similar triangles. Let's have the same value theta, and it will have the same length here, which is opposite side, and will have the same hypotenuse length, because hypotenuse is anyway 1, and it will have the same common base. Right, so if we're going to call this point as P1, and let's call the coordinate here as x and y. So x will be the adjacent side, the length of the adjacent side here, and y will be the height of the opposite side here. Okay, so if this is x and y, since they are equal in dimension, this point P2 will be x comma minus y. It will be a negative y because it falls on the fourth quadrant where the y value is negative, whereas the x value is still positive. Right, what does this mean? Let's see an illustration. We'll come back to this cos theta and sin theta in a while. So this mirror image can be illustrated through a reflection on the water. So when you have a bird sitting on the waterbed, and when we see its reflection on the water, this image is very similar to such a reflection. So you see the reflection starts from the feet and it goes to the head. So it's like a reverse or a vertically flipped image. So this is also a vertically flipped image of the image which is in the first quadrant. All right. So now let's move on to find the trigonometric ratios. Now we know that the coordinate x and y can be written as cos theta, sin theta. We have done this in the previous videos. And if this can be written as cos theta and sin theta, where this is the theta here, we're going to use this reference angle, which is 360 minus theta, and we're going to call that as theta 1, and use that as our coordinate for P2. So our coordinate for P2 will be cos theta 1 and sin theta 1. Is that clear? So our coordinate for point P2 will be cos theta 1 and sin theta 1. So now let's find out what is exact values of this cos theta 1, which is cos 360 minus theta. Right. Let's start with the sine. So sine 360 minus theta can be written as sine theta 1 because our theta 1 is equal to 360 minus theta. And we know that sine theta 1 is minus y. So we bring this minus y here. Now, we also know that the value of y here in the first quadrant is also referring to sine theta. In other words, y is equal to sine theta here. So we replace this y with sine theta, so it becomes minus y is equal to minus sine theta. So now we have sine 360 minus theta as minus sine theta. Now let's work out for cos. So cos 360 minus theta is equal to, again replacing 360 minus theta by theta 1. And we know that cos theta 1 is x. So replacing that value here. And we also know in the first quadrant that x is cos theta. So replacing cos theta here, we get cos 360 minus theta is equal to cos theta. And the last tan 360 minus theta will be equal to sine 360 minus theta divided by cos 360 minus theta. And we know here from the first equation, sine 360 minus theta is equal to minus sine theta. So we replace this with minus sine theta. And our cos 360 minus theta is equal to cos theta. So we replace this value with cos theta. So our answer is minus sine by cos is tan. So we get minus tan theta. So now we have found the trigonometric ratios for all the three sine, cos and tan when our angle is 360 minus theta. In other words, when the angle is on the fourth quadrant. Hope you enjoyed this video. To see more of these videos, kindly subscribe. And also, if you have any comments, please, you can drop it at the comment box. And if you have any specific videos that you would like me to make, you can also mention that. Thank you for watching.